Welcome students. I welcome you all in this online class. The topic of today's video lecture is Photochemistry of Carbonyl Compounds Part 4. We have already discussed three very important reactions under this topic, and they are photoreduction, Peterno-Bucchi reaction, and Norrish type first reaction. So today we are going to discuss one more very important reaction, that is Norrish type second reaction. Carbonyl compounds containing gamma hydrogen undergo intramolecular hydrogen abstraction and diareticals are formed. Or we can say ketones possessing a gamma hydrogen atom undergo a very interesting photochemical reaction which results in the formation of an olefin and the enol of a smaller ketone. Spectroscopic studies have demonstrated that the disappearance of the starting ketone occurs at the same rate as the appearance of the enol form, that is the product. The reaction proceeds by the initial gamma hydrogen abstraction by the oxygen atom and formation of a 1,4 biradical takes place. This 1,4 biradical subsequently cleaves and an olefin and a methyl ketone via the enol are formed. So let us study this reaction in detail. So here the equation is written for you. So first structure is of the ketone, and you can see there is a gamma hydrogen atom. Alpha, beta and gamma are marked in the structure. So it absorbs light and a 1,4 biradical, that is second structure, is formed. Now this 1,4 biradical subsequently cleaves to an olefin, that is the third structure, and a methyl ketone via the enol. So this is the equation part, you can see and understand it very clearly. Both n-pi star singlet and n-pi star triplets participate in the intramolecular hydrogen abstraction reactions, while ketones with a low-lying pi-pi star state do not undergo this reaction. Now the gamma hydrogen abstraction is sometimes followed by ring closure of the 1,4 biradical. So here you can see the formation of the biradical, that is structure second, we have seen it just now. Now this 1,4 biradical, it will undergo ring closure, and this leads to the formation of substituted cyclobutanol. The formation of the 1,4 biradical is a reversible process, and the equilibrium between the reactant and the products depends upon the structure of the starting ketone and the conditions of irradiation. Now, if in the example which we have studied just now, we replace gamma hydrogens by deuterium. So let us see what happens. When gamma hydrogens are replaced by deuterium, the resultant 1,4 biradical has an OD bond And since more energy is required to break it than an OH bond, the reaction proceeds in the forward direction more smoothly. So here you can see the equation. So here is the structure. First is the ketone, in which you can see the gamma hydrogens are replaced by deuterium, that is D. Now it absorbs light and 1,4 biradical is formed, that is structure second. Now you can see it has an OD bond. Now this 1,4 biradical leads to the formation of olefin and ketone via the enol. So these products are formed. Norrish type second cleavage is often accompanied by a type first split. So type first split we have seen in our previous video lecture, that is photochemistry of carbonyl compounds part 3. So you can refer to that video lecture if you wish to. So here we are seeing one more example, that is 2-pentanone. So we are seeing the irradiation of 2-pentanone. So irradiation of 2-pentanone yields the following products. So you can see here, first one is type first. In the type first reaction, acetyl radical and alkyl radicals are formed. So 2-pentanone on absorption of light forms acetyl radical and an alkyl radicals, and these radicals combine together and three products, that is biacetyl, acetone and alkene, are formed. So this is Norrish type first reaction, that is alpha cleavage. And here alkene, acetone and biacetyl, they are formed as products. Now if we see Norrish type second cleavage, then here you can see acetone, ethene and substituted cyclobutanol are the products formed. Now let us see an example of cyclic ketones also. The photochemical reactions of saturated cyclic ketones resemble closely the photochemical reactions of open chain analogues. Usually the photochemistry begins with the n-pi star excitation of the carbonyl group followed by alpha fission, in which formation of the most stable radical is preferred. The biradical thus formed may undergo a hydrogen transfer reaction from the carbon atom alpha to the carbonyl group, yielding a ketene, or it may give rise to an unsaturated aldehyde by hydrogen transfer to the carbonyl group. So here you can see the equation. So this is the structure of a saturated cyclic ketone. On absorption of light, that is alpha fission is taking place and a biradical is formed. This biradical undergoes a hydrogen transfer from the carbon atom alpha to the carbonyl group and a ketene is formed. Or you can see it may give rise to an aldehyde. See the structure second, aldehyde, by hydrogen transfer to the carbonyl group. Or alternatively, the bi radical may decarbonylate, that is, loss of CO, and ring closure can take place. So you can see in the equation, same cyclic ketone on irradiation, a biradical is formed. On decarbonylation, that is minus CO, loss of CO, this biradical a ring closure takes place and a cyclic product is formed. So while this is the case of cyclic ketones, so acyclic ketones, we have discussed this reaction in detail for acyclic ketones in our video lecture 3, that is Photochemistry of Carbonyl Compounds part 3. So just before studying this reactions for saturated cyclic ketones, you can just go through that video lecture part 3. So then there the detailed steps are written and you can understand it more clearly. So that's all for today. Thank you so much. So these were the these are very important reactions of carbonyl compounds, that is photochemical reactions of carbonyl compounds. And Norrish type second is also asked in exam most of the time, so prepare it and do some more examples also from books. That's all. Thanks a lot.